we have started looking at RDF and RDFS, and as we said, the goal of using these techniques or this representation scheme is to have a shared common vocabulary which can be used around the web. So, we had this notion of namespaces that we saw, and then we saw that the statements also are of standardized formats, that they have three components: the subject, the predicate and the object, and that is how we are going to represent things in the net. So, let us look at a few examples, and our goal is not to, as I said earlier, our goal is not to learn RDF here or RDFS or OWL, because these are languages and they are best learned by just going to the websites and looking at them. If you go to the W3 websites, you will find descriptions of what is RDF, what is RDF schema, what is the syntax, what is OWL, everything you can find there. But what our goal here is to get a feel of what RDF and RDFS and OWL is like. So, we have already spoken this. We can use different kinds of prefixes to talk about sentences, and sentences are triples which are made up of three things as shown here. Some of them we have already seen earlier. So, for example, poet is a subclass of person, and subclass itself comes from the RDFS vocabulary, and likewise country is a class and studio is a class and a person is a class, and so on. This representation that we are showing is called turtle format essentially. So, if you were to use turtle format to talk about RDF sentences, then this is what you would do. You would first state the first element with a colon, for example, or with the RDF namespace, and then the three things property followed by a full stop essentially. So, the genre is a type of property. The domain of genre is song, the range of genre is the class called genre. So, likewise we have poet whose domain is a song and whose range is a poet, and singer also a domain is an event. We are talking about instances of singing performances. So, in that event the singer was somebody who comes from the category of singer. We can use a compact format where we do not have to write them repeatedly. We can just use the subject once, then put semicolons and end the whole thing with a colon with a full stop. So, that kind of makes it more compact. Likewise, for the other things that we have spoken here. So, here is something that we are familiar with. We have been talking about this for a while, that the poet of Rang was Amir Khusro, the genre of Rang is Sufi. So, that is one thing we are saying something about Rang. So, in a graph you would see Rang with Khusro connected one and the genre connected at the other side. And we can talk about the specific performance that we described when we were talking, when we had started introducing triples, that this performance was in 2012. It was done for Coke Studio. The producer was Rohel, the host was YouTube, the singer was Hadika, and the title was Rang. And then of course, this will get connected to this essentially. So, you can see we drew this network, but now RDF allows you to do that as well essentially. So, the vocabulary of RDF and RDFS allows us to create new classes, new data types, new properties and new literals. So, it is up to us to define what we mean. So, if you want to talk about poets and singers and songs, we can do that. If you want to talk about books and authors and publishers, we can do that as well, or anything else for that matter. These languages are general enough to allow us to define subclass relations, subproperty relations and domain and range constraints, as we will see as we go along. We can talk about bags and lists and reified statements as well. This is a vocabulary of RDF, RDFS. You can go through this at leisure. I will just talk about some things that we have spoken about. So, RDFS has a word called subclass of. So, one class is a subclass of another this thing. Likewise, we have sub property of, and we know that we have domain and ranges of properties essentially. Then as I said, we can talk about list. So, we can talk about the first element of a list, the rest of the list, or an empty list, and so on essentially. So, we have RDF statement, which is a triple RDF subject, predicate, object. As we said, OWL allows us to do much more than RDF and RDF can do. It allows us to create new classes of different kinds, enumerated classes or unions or intersections of classes or complements of classes. We will see examples of that. We can talk about relations between classes. So, a class is also a resource in RDFS also and in OWL also essentially. And in OWL we can say that two classes are equivalent, one is a subclass of the other, and these kind of relations. We can put property restrictions and say that these classes have these property restrictions basically, which means, and we will see examples, that the range has to be from a certain class, for example. So, for example, the child must be female, and then we can say okay, we are defining a class of people who have daughters and so on. We will see that there would be other kinds of restrictions, value restriction, existential restriction, number restrictions, how many elements you can be related to, and we will see as we go along. But this is all part of the OWL this thing, and these are the this is the vocabulary of OWL which talks about, allows us to do that. So, for example, we can say restriction on property at some values from that. As I just said, if you want to talk about people who have daughters, then the child property with a restriction that the range must come from the class female essentially. So, we will again look at this as we go along, some values from or all values from that they have only daughters, for example. Then cardinality, how many they have, and that kind of stuff. We will see these things. So, there is cardinality, there is qualified cardinality as to how many elements of a certain class you are allowed to have. OWL builds on the RDFS vocabulary, as we have said, allows named individuals and allows us to express sameness and disjointness between individuals, that they are same or different. You can create object properties, data type properties, and annotation properties. Annotation properties are properties which are meant only for the reader of the document essentially. We can define inverse properties, for example, child and parent, property chains, for example, brothers, sister-in-law, and equivalence relation between properties and so on. We can have already we said that inverse functional properties and so on. Functional properties are properties which map only to one person, they are like functions, mathematical functions, and this is the vocabulary that OWL uses for doing that. So, we can say inverse of, or we can say property chain, this thing, or equivalent property, and so on essentially. So, you can look at them in leisure. In fact, I would strongly recommend that you go to the OWL website for W3 and you can see that what are the different things that OWL allows you to say. But as long as you get a feel of it, we should be happy here. So, as we said that RDF is basically meant to store data on the web essentially, and we spoke about the linked open data cloud or the LOD cloud. I will show you some pictures from there, but you should best go to this website and look at them yourself to get a feel of what is happening. Then we said DBpedia, Wikipedia, WordNet also has RDF data sets, and there is something called data hub essentially. There are various resources available for studying ontologies and RDF and RDFS. A nice book is by Antonio and Harmelin, but there are plenty of resources on the web. As you can see, these are primers all on W3 websites essentially. You go there and anything that you want to read about concepts, abstract syntax, turtle documents, OWL, the language primer for example is a nice one there, quick reference guide for OWL and so on. So, once you know what RDF and RDFS and OWL are about, you should go to these sites to get more information, and that will equip you to start using them. What I will do now is to show you some images from this LOD Cloud website, so that you get a feel of how this data has been expanding over the last couple of decades. So, this is how the LOD Cloud or the linked open data cloud used to look in 2007. It had about 28 data sets, some of which have been shown here. As you can see, this DBpedia is kind of central and connected to many other things essentially, but there are other things as well. So, for example, there is DBLP by people in the research community. It is a collection of all the papers written by different authors. So, you can search on author, you can search on papers and so on, and you can get lot of information about publications here. Friend of a friend, FOAF essentially is a data set which kind of allows you to connect different people to each other essentially. So, there is a theory that if you take any two people in the world, and essentially we are talking about the social network like situation here, where they are connected on the social network, then you can reach from any person to any other person in 6 hops, and that is a theory. And this friend of a friend is basically a database which allows us to look at that. There are other things like US census data and Project Gutenberg, which is a collection of freely available books that anyone can read. By 2009, as you can see, this cloud had grown considerably. DBpedia is still very central to this whole thing, but there are other things which are getting more important essentially. As you can see, the density of connections here is larger and so on. By 2010, this process has increased further. So, that cluster that we saw there and this one and this one. By 2017, it had kind of developed sub-regions of interest, which are shown here in different colors, and each of those circle like things is a database of is a document, RDF document. I should draw your attention to the fact that this very dark colored background that you see in this part of the web is essentially edges, and there are so many of them that it looks as if the background itself is dark. This is in 2021, which is last year when I am recording this, and you can see that it grows and it grows essentially 1300 documents on the web, and you have to really zoom in to look at for something. Luckily, of course, you can search for what you are looking for. You can search for a domain. So, there is something called a medical ontology that you can find and things like that essentially. So, this was just to give you a feel of what is happening in the world of RDF and storing documents on the web. Next, we will make a connection to logic, and we will start looking at something called description logic, which is a subset of first order logic, which is decidable, but which can do only certain class of inferences which the language allows. We will do that in the next